One of the most important components of any vehicle is its tires. Unfortunately, tires are often overlooked and poorly maintained. Worn treads or even bald tires can lead to hydroplaning on wet surfaces. When this occurs, control of the vehicle is lost. NASA Langley Research Center has a special facility that makes traveling safer by testing new tire tread designs and road surfaces. Paula Vaden finds out more about NASA's Aircraft Landing Dynamics Facility.
Have you ever heard this sound? It's the impact of tires over grooved pavement. Developed at NASA Langley, grooved pavement limits hydroplaning on wet roads and runways, which helps automobiles, planes, and people travel safer. Most of this research is performed at a unique facility called the Aircraft Landing Dynamics Facility, or ALDF. Besides developing grooved pavement, ALDF tests aircraft wheels, tires, and advanced landing systems. The research gathered here develops safer roads, runways, and pedestrian walkways. I spoke to Bob Doherty of NASA Langley Research Center to find out more about this one-of-a-kind facility.
Well, the ALDF is a unique facility that NASA uses to test landing gear components, tires, and even advanced landing gear concepts at full-scale conditions. The biggest advantage is this facility allows us to simulate full-scale conditions where it might otherwise be dangerous for a pilot or an aircraft to encounter. For example, if we tested this tire and it failed, here at our facility, we've only lost a tire. We haven't risked any injury to a pilot or done any damage to a real aircraft, which gets very expensive. And of course, being able to run tests over and over quickly at low cost gets you a lot of data in a very short period of time. The key to doing that is getting whatever component we're looking at up to speed and making it think that it's on an aircraft or a spacecraft. We do that by taking this 60-ton carriage, propelling it up to the speed we want. We can get up to 250 miles per hour, and it only takes 2 seconds to do that. And then landing this tire, for example, on a runway, applying forces to it, steering it, and measuring those forces so that they can be simulated elsewhere in pilot training simulators and so forth.
Well, Bob, tell me, how exactly do you propel the carriage?
Well, that's really the neatest thing about this facility. Believe it or not, we use a giant squirt gun. We've got a pressurized water tank at the end of the track with a real high-tech valve. We actually shoot an 18-inch stream of water at a bucket at the back end of the carriage, and that actually gives us the energy to launch the carriage. Now, what's unique about this is it's low cost. If we were a rocket, we'd have to carry our fuel with us, and that's very expensive to do. But since we're using low-cost, low-efficiency water power, we store all of our pressurized water at the end of the track and shoot it at the carriage. All we have to do is pay for the water and the electricity, and it only costs about $25 for each run.
So at the speed of 250 miles an hour, how do you stop this carriage?
Well, at the end of our track, we have an arrestment system, and that arrestment system consists of 5 cables that stretch across the track, and we have a nose block on the front of the carriage that lines up with those cables. So as the carriage continues to travel, the cables allow us to gradually dissipate the carriage energy in the last few hundred feet.
So Bob, what other kinds of things have you tested at ALDF in the past?
Well, over the years, we've tested a lot of different things, but probably the biggest accomplishment here at the ALDF has been the pioneering work done on hydroplaning.
An aircraft or highway vehicle tire hydroplanes when water comes between a tire and pavement. When this happens, the tire loses contact with the pavement and is supported only by the water. This causes the tire to lose traction, which could then send the vehicle spinning out of control. Researchers at ALDF have proven that by cutting thin grooves across concrete surfaces, channels or escape routes are created, which allow excess water to drain from the surface. This process of cutting grooves dramatically reduces the risk of hydroplaning. As a result, hundreds of commercial airport runways and interstate highway curves and overpasses have had these safety grooves added. Accidents on slippery highways are down as much as 85% in some areas, and aircraft tire friction in wet conditions has been improved by 200 to 300%. An added benefit of grooving is that the lifespan of these grooved surfaces is extended by 5 to 10 years, resulting in significant maintenance cost savings.
One of the things we're doing now is trying to increase the safety margin of Space Shuttle orbiter tires. NASA wants to improve that safety by increasing the load carrying capability of the orbiter tire by about 20% and increasing the speed capability by about 10% up to 250 knots. This is going to require a new tire design, and the best place to evaluate that is right here at the ALDF, rather than on board an orbiter that costs several $billions. We're going to be looking at design considerations like the structure of the tire itself and the tread patterns to determine which design path to go down.
So as long as tires have been around, Bob, it seems like we'd know by now how they behave.
You'd think so, but as it turns out, how a tire behaves, whether it's an automobile tire, aircraft tire, or a spacecraft tire, is dependent on so many factors that technology is not yet at the point where we can accurately predict the behavior of each and every tire. So that's where the ALDF comes in again to test these things and improve the predictions. And we share that data with tire manufacturers so that ultimately they can provide a product that all of us can use more safely.
The Aircraft Landing Dynamics facility has been in continuous use since the 1960s. Researchers there have not only made runways and roads safer for all of us, but also coined the term hydroplaning.
Wind tunnels have been around for over 100 years. Even the Wright brothers used their own homemade wind tunnel to test ideas for their first flyer. Today, aircraft designs undergo significant wind tunnel testing before being built to full size and test flown.
But what is a wind tunnel and how does it operate? For some answers, we turn to Johnny Alonso to find out how it works.